Hello and welcome to another video from Easy Academy. In this video, we're going to be focusing on the Log4Shell vulnerability, and specifically, I'm going to demonstrate how the attack works, showing you the different components that are necessary to make this attack happen, how it happens in a sample console application as well as a Spring Boot application. Then we're also going to walk you through some of the mitigation steps that you can take to get rid of this problem. So let's get started. Now, the outline of today's content is going to be about showing you a summary of the vulnerability, and then we're going to talk about who is affected. We're also going to cover how it works by showing a demonstration, and then I'm going to walk you through what you need to change in your application to make this effective in getting rid of the problem. Now, there are some strategies that are out there, but those are just temporary band-aids. What we're going to talk about today is the exact thing you need to do to get rid of the problem once and for all permanently. So not a temporary mitigation, but the permanent mitigation for this solution, for this issue. And then we'll also talk about some of the possible upcoming content that I'm going to be discussing in the future. So if you're new to this channel, please, I encourage you to go ahead and click on the subscribe button and then click on the notification icon so that when new content is being published, you will be the first to find out. I also have a Patreon community where you can support my channel through Patreon, and you get to have access to exclusive membership, which I'm going to discuss later down in the video. But the link to the Patreon community is available below in the description, so feel free to join and then get access to exclusive content and some of the things that I'm going to be discussing later on. You can also follow me on Twitter at Easy Academy, and then check out my website at easyacademy.com to see what I have to offer. Now, I also have a course that covers how to process data, how to store data, how to aggregate data using open source content and software. So if you're interested in how to use open source software to aggregate, store, and process your data in real time and batch mode, take a look at this course and let me know your feedback. So today we're going to get started by talking about what Log4Shell is all about. So basically, this is a remote code execution attack that was a 0-day vulnerability, which at the time of discovery or publication, there was no known solution that solved this problem. So basically what happens is the attacker sends unsanitized input to the application in any form or in any mechanism. Once the input arrives, the Log4j library attempts to log this particular event or message, and then it ends up performing an LDAP lookup through JDNI, and then that ends up sending this request to the LDAP server that redirects to some kind of protocol like HTTP that downloads the code sample, and then it gets executed. So that's what I'm going to be demonstrating in this particular demo today. Now, to do this, we're going to go ahead and take a look at the demo. So stay tuned. Now in the demo, we're going to cover the sample console application, and then we're also going to cover the Spring Boot application. So the affected users, basically, if you are running any version of Log4j between 2.0 beta 9 all the way to 2.14.1, you're going to be affected. So the Java environment does not really matter much because there are workarounds where the attacker can still find ways to avoid those problems and still attack you. But if you take a look at the Log4j security publication that I'm having in the description of this particular video, you're going to see who is affected and what you need to do about that. So now let's go ahead and take a look at the demo of the attack. So in the first part of this demo, we're going to be talking about how the console application is sending input, and then right after that, I'm going to show you how a Spring Boot application can also do the same thing. So basically, this is not only about web applications, it is pretty much about any application that uses the Log4j version 2 library to perform logging operations. So if your application is using this, either directly or indirectly, you are going to be affected. So you have to upgrade your dependency version to get rid of the problem. So now let's get started with the attack demo and see what happens. To go over this, I want to show you what components we need to make this happen. First, we need the malicious LDAP server. This will be the server that would receive the request from the application to perform the lookup that will redirect us to the web server that will download the code. And then obviously we need the web server that will be hosting the malicious Java code. And then we are also going to take a look at the console app that is using Log4j to perform the logging operation. And then I have the Spring Boot application. Now let's take a look at these components briefly before we get started with this demo. So I have the web server, I have the attack LDAP server. I also have some sandbox that I'm going to be using for this. But let's take a look at some of the code samples that we're going to be going over. So the first one that I have here is the Spring Boot application. So as you can see here in the Spring Boot application, we are using Log4j we're using the affected Log4j version, so 2.14.10. And then what is happening is the code is going to be receiving input from the client, and then it would perform the logging operation that will go ahead and log that particular input from the user. And then when that happens over here, this is where the attack happens. So as you can see, the input is captured by the user and it is un-sanitized, and then we go ahead and log that input by substituting it inside the string, and then that's what ends up performing the lookup. And then right after that, the next thing that we're gonna demonstrate is gonna be the Spring Boot application. Similarly, the Spring Boot application is gonna be receiving a request header, and then in one version of the logic, we're going to be using the logger from Log4j to log it, and then we'll see what happens. And then we'll also use the logger from Log4j to do it in a different request, and then we're going to go ahead and see what happens. Then obviously when it's time for us to update, we'll go ahead and go to the pump file and modify this to mitigate the problem. So let's get started with this now. So we have our Docker container running all these different components. The LDAP server is waiting for incoming requests at this port, and then it will redirect it to the exploit code that I'm gonna show shortly. So the exploit code is simply receiving instructions to fetch the operating system, the version number, Java version number, and then it's gonna go ahead and execute a call command, and then that would get sent back to me so that I can find out the environment of the container that we are performing the attack on. So this is very, very serious stuff, and we're about to get started now to see what's going on. So now we have this sample console application. Now what I did was that I have set up the environment to have different versions of Java so that we can see what is going on. To do this, I downloaded the JDK versions, and we have multiple versions of Java. So we have Java 8, we have Java 11, and then we have Java 17. I'm going to be showing what is happening in each of the specific Java versions. So let's take a look at that. So one of the things I'm going to do first is going to be to perform a setup of the Java environment. So when I do A will give me JDK 1.8 update 181, and then when I do B it's going to switch to a different JDK version 1.8 update 301, and then when we do C it switches to 11, when we do D it switches to 11.012, and then finally when we do E it switches to 17. So this is how I'm going to be toggling all the different Java versions. But let's go back to the first version and let's use that to compile our code. So as you can see here, if we take a look at the pump file, we have version of the Log4j is 2.14.1, which is the one that is vulnerable. So now I'm gonna go ahead and compile this code. So I'm gonna start with this one first because it is simple for everyone to understand. Once we compile this and we're done, we're going to go ahead and try it out in the Spring Boot application. So that comes later in the video. So as you can see here, we have Log4j core. This is where the vulnerability is, and this particular version is affected. So now that this code is compiled, let's go ahead and run the scripts that will execute the jar file. So this here was how I was able to set up my Java environment. But before I do that, let me show you the exact class that is causing this particular problem. So this lookup class can be found inside the compiled jar file. So if you take a look at this is the class that performs the lookup. So in current versions of this particular dependency, this particular lookup class has been deleted. So that was the main permanent fix that was done. So now that we have done that, the next thing I'm going to do is I'm going to run the sample class that I have and then pass in the exploit code. But before that, let's take a look at what is happening with the LDAP server. As you can see here, the LDAP server is waiting for requests and nothing is happening yet. But now that we're going to execute this, we're going to see what is going to happen when that takes place. So the code is loading the jar file, and then we're going to pass in the command line argument. So let me do that. Okay, so when we run this input gets submitted as the second argument to the program, and what that does is that it goes into the sample code and it gets logged. So that is why you're seeing running example, the program name, which was the first argument, and then the user provided input, the second argument. So that is what we're seeing here. But what happens behind the scene, as you can see here, is that the reference was sent to the LDAP server, and then it went ahead to contact my attack web server to make the request to download the exploit class. And then when the exploit class was loaded into the application, it went ahead and sent a request to the web server again to report back as to what is found in my environment. So as you can see, the operating system is Linux version 5.10.47. We have the JDK version that I specified it to, and then my home directory is root, and then we have the user directory as console app, and then obviously some other environment variables can be seen here as well as the curl version. So as you can see, this exploit is very bad, because if I'm able to do this, the attacker could pretty much do whatever they want to do in that particular environment. So now that we have run this particular demo for version 1.8 update 181, let's take a look at another Java version and see what is going to happen. So to do this, we're going to set it up to this version of Java 1.8 update 301. Now let's take a look at what is going to happen. So to do that, I just want to clear my screen so that you can see it clearly. So we have that. We're going to execute the command again. When we do it this time, let's take a look at what happens. So what happens is that in this particular version of Java, update 301, the lookup still occurred, but because the loading of the code is disabled by default, that particular subsequent action of downloading the class file and executing it did not take place. So that is very important for us to make a note of that. Now let me switch the Java version again. So right now we are 1.8. Let me switch the Java version again to another one, version 11. So now this is the GA version of 11, and then let's run this code again and see what happens. So when we did this, the same thing happened again. It sent a request to the LDAP server, and the attack information was disclosed to me through the callback. So as you can see here, the JDK version is 11, and then everything else stays the same. So again, this is very dangerous, very dangerous. So let's take a look at another one. So if I switch this to version 11.012, I'm going to find out what is going to happen again, but let me clear this up. So remember, in version 11 we were able to see the issue taking place, but in this particular version of Java, update 0.12, let's see what happens. So when we execute it, we still see the same console result, but the lookup happens, but we don't load the code. And then finally, let's take a look at Java version 17, the latest version available. Now when we do this and we run the code, the exploit is still feasible because we have this lookup, but the code was not executed. So this is kind of like a false sense of security. What I would recommend for you to do in the mitigation phase is to make sure that you update the Java version to the latest version, and then you also change the dependency version of Log4j core to 2.15.0 at least, or update to the latest one as of today, which is 2.16.0. So now let's go back to our original Java version. So what we're gonna do now is we're gonna go ahead and make changes to this POM file, and then we're gonna switch the Log4j version from 14 to 15, and then we're gonna see what happens after we finish compiling the code. So now we have changed it to 15, and then we're gonna go ahead and execute it. So let me change my sequence. So we're done with the attack demo. Now we're going to move on to mitigation. And in the mitigation, like I said before, the main thing we need to do is to change the version to the latest version right now, which is 2.16. So I'm going to use 2.15 in my demo because that was what I prepared with. So once you change that, that should take up the problem by removing that class that we saw when we were loading the jar file. So let's take a look at that now, and we're going to demonstrate the demo shortly of how to mitigate this problem. In this mitigation phase of the demo, the main objective is to make sure that we have the Log4j version updated to 2.15, and let's verify that we did that. So in the POM file, we have 2.15 specified, so that's good. Then we're gonna go ahead and compile this. Now once this is compiled, I will proceed. So now we have 2.15 in the jar. So once this is compiled, now we're gonna go ahead and attempt to run the exploit again to see if it has been resolved. So let's clear this up and let's try this again. So we are running and nothing happened. The lookup did not take place. So this demonstrates that the issue has been resolved. Now that we have concluded this sample demonstration for the console application, I'm going to go back to the demo again, but this time we're going to do it with the Log4j application that is running inside Spring Boot. So the Spring Boot app has a controller. In the first controller, the endpoint is just going to be /orders, and then what is happening here is that we're going to retrieve the request header. Once we retrieve that, we're going to extract the user agent, and then we're going to use the Log4j framework to log it, and then we'll see what happens when we're using that library to do it. Then in the second endpoint, we are specifying the specific ID for my order, and then we're retrieving the request headers again, but this time we're using Log4j version 2 to do this. So let's go ahead and do this now, and then we'll perform the request with the previous version of Log4j and then the updated version that has no vulnerability, and we'll compare them side by side to see what happens. So now we're going to switch to a different directory. going to switch to the sample Spring Boot application, and then we're going to open the POM file and check for the dependency version. So as you can see here, it is 2.14, and then we're going to compile it for Java version 1.8, and then we'll see what is going on inside the application when we are using it for logging. So I'm going to close this now, and then I will compile this. We're going to run it using curl, and then we're going to see what happens when we specify the malicious user agent that would perform the lookup and put in the exploit code inside the application. So we're going to pause here, and then we're going to resume again with the demo for the Spring Boot application. A lot of you are using Spring Boot applications to perform REST API setup and things like that. So this particular demo is just going to focus on the logging part of the application and not really how the Spring Boot works in general. So the focus on this demo is just to show you how the Log4j is used to introduce this dependency. So let's get started with that and take a look at the code. So in this Spring Boot application, we have the POM version set to version 14, and then we're going to go ahead and compile this. So it's confirmed to be at 14. When we compile this to create the jar file, it compiles, and then it should load in the vulnerable application. So if we want to confirm the dependency that we have, we can use the Maven dependency tree command, and that should show us all the different dependencies that are part of this application. So that is going to be loading shortly, and we're going to take a look at it. Once all the dependencies have loaded, we should be able to see some kind of printout and graph that demonstrates everything that is part of this application. So I'm going to clear this up and do this again to have a much nicer view of this. So if you take a look at this closely, we're going to see which version of Log4j is present in our application. So as you can see here, we have this particular one here. The API and the core version is being loaded into the application. So we have 2.14. In the future, you can just use this Maven dependency tree command to see what you have if you're using Maven for dependency management. So I believe we compiled it, but let me just do that again. So once that is done, the next thing I'm going to do is going to be for us to run the service. We already did the lookup in the other one, so it should be the same thing. But if you're interested, let's just take a look and see. Let's take a look and see what happens. So I will do that later, but for now, let's go ahead and run this particular application. So when we run this application, Spring Boot should be loading on a specific port. Yes, port 7070. So once we have that, I'm gonna go ahead and send a request to the first endpoint. This endpoint uses SLF4j to perform the operations. So to do this, I'm gonna need to get into another console to execute that. So I will go ahead and enter this particular sandbox that I have here, and I will execute the command from inside. So let's take a look at this command. So this is the first one. The first one performs the request. We receive the response back. Now, what that is doing, if I go back to the orders controller, it is hitting this first endpoint, that is /orders. When it receives that, it uses this SLF4j library. It extracts the user agent and then it performs the logging operation. But what is the problem now is that we have the exploit happening again, where we are loading the reference from the LDAP, and then we are connecting with the attacker web server to download the exploit class, and we're executing the exploit class to load what is happening. As you can see here, the path is different from the console application, and this is very bad. So this is using Log4j to do this. Now we're going to send the same request again, similar request, but we're going to be using Log4j to do this. Now in the other endpoint that I have here, this endpoint is using Log4j version 2 to perform the operation of logging, and we're going to see similar issues. So let me clear this up so that we can see what happens with that endpoint. I expect to see the same behavior. So this endpoint here is retrieving a specific order and not everything, and then we see the same thing happening again. So again, the redirect happens, the exploit class gets downloaded from the attack web server, and then the callback happens, where we are seeing the environment variables and settings being sent back to the attacker for further exploitation and discovery. So this is very bad. Now, how do we fix this problem? We fix this problem just like how we did with the other one, by going to the application and simply modifying the Log4j version to the new one, so that we avoid having this particular problem. So let's go ahead and do that, and we're going to recompile the application and see that the issue has been resolved. So I'm going to shut this down. And then we're going to recompile again. Once we recompile with the updated version of the Log4j library, we're going to see that the issue has been resolved. So I'm going to take a pause here, and then we're going to resume shortly with the fix and the demonstration that the issue has been resolved. So after the POM file has been modified to version 2.15, or the latest version of Log4j, we're going to go ahead now and execute this particular application and see what happens. So in the first one, we're sending a request to the first endpoint, and then in the second request, we're going to send a request to the other endpoint, and then we're going to observe what is going on. So we should see that when we go ahead and do that, the reference should not happen, the lookup should not happen, the download should not happen, and the exploit should not take place. So let's take a look at that, and we'll verify it, and then we'll round up for this particular video. I thank you for your patience so far. So let's go ahead and check that out right now. This is the logging using Log4j, and this is the logging using the Log4j library. So we're going to head now to the LDAP server and take a look at what took place. As you can see, the LDAP server is up and running, and is prepared to inject the vulnerable exploit in the sample applications that are running it. The server is waiting for requests, but nothing was being sent to it. So that concludes the demonstration here. I just want to go ahead and summarize what you have to do. So in any of these scenarios, regardless of what Java version you're using, please make sure that you upgrade your Log4j dependency, the Log4j core dependency, to the latest version that has been determined to resolve all these vulnerabilities. Don't depend on the Java version or modification of environment variables or system properties to mitigate the issue, because the attackers may always find other ways to work around that and still exploit your system. So this is going to conclude this particular demonstration. Now for future contents, I'm going to be working on demonstrating this vulnerability in some other open source workloads, and then we're going to take a look at how to detect Log4j dependency vulnerability in other environments like Windows, Linux, Macintosh, and so on. And then if you also have the fear of this particular vulnerability, you can check to see if your affected Log4j version is in the list. So that is very simple, and I think we demonstrated that here. If you want me to do a deep dive on any of these other topics, please feel free to put that in the content as a comment, and then I will take a look at that as I'm preparing for upcoming content. So again, if you have not subscribed to my channel, please go ahead and do so, as you will be able to receive notifications immediately I upload new content. You can also support the channel by heading out to Patreon and becoming a patron, and then I will discuss some of the benefits coming up with that. Now with Twitter, you can follow me to see some of the content that I have coming up, and then you can check out my website for upcoming content that I have. Now I have a course that walks you through how to use open source software to process data, to store data, to aggregate data. You can process data in batch mode and real time. So if you're interested in something like this, please go ahead and check that out. One of the reasons why I did this video was because several students were reaching out to me because they're using these vulnerable systems and they want to find out what they need to do about it. So in my course, I'm going to be upgrading the dependency versions so that this issue is no longer happening with their systems. If you head over to Patreon, you can join and become a patron, and then that would give you exclusive access to early release videos. You will also have access to download the accompanying code that comes with that. So I just want to go over the benefits, so you can download the video before it comes on YouTube. You can also have access to download the code if you subscribe to certain membership levels, and for the VIP members, you get to participate in Ask Me Anything sessions, and we can discuss certain topics of interest to you, and you also get to participate in voting in community topics and issues that are important to you. We have a goal of 512 members. As soon as we reach this goal, we're gonna kick off a community podcast. We'll also start a video series where we'll be interviewing 2 patrons a month, where you get to talk about any of the topics that we have discussed, or any other topic of your preference that is related to technology. And then we'll also cover these interviews in the community podcast that will be started, and this will also be published in the YouTube channel. So I'm very grateful for your support to this channel. Please head out to Patreon, subscribe to the channel, and check out my course as soon as you can. Thank you very much for your time, and I will see you in the next video.